welcome to the expanded power rule. So the idea here is we have looked at positive integer powers, right? So let me switch colors. We have seen that the derivative of x to the n equals n times x to the n minus 1 for n positive integer. But the question is, what happens with negative exponents? So for a quick example, let's go ahead and take the derivative of x to the negative 2. Okay. Well, this is the same thing as taking the derivative of 1 over x squared, and then we could use the quotient rule. So the quotient rule, we would do the derivative of the first, so derivative of the top times the bottom minus the first times the derivative of the second, all over the second squared. But the derivative of 1 is just 0. So this first term is going to go to 0. And so we have negative 2x all over x to the 4th. But if we simplify that, that is just negative 2x to the negative 3rd power. So notice here, this essentially looks to still follow the power rule. Right? We pull the exponent out front and then dropped the power by 1. Negative 2 would drop to negative 3. So the power rule does actually extend to the negative integers. So what we now have is that the derivative of x to the n is still n x to the n minus 1 for all integers. Keep in mind, if n equals 0, we're just taking the derivative of a constant, and we should get out 0 for our answer. So let's go ahead and use this power rule to take a couple new derivatives. So first up, let's find the derivative of h of x equals 1 over 6x to the 7th on that denominator. So note that we could rewrite this as 1/6 x to the negative 7th if we wish to. So what we get then is h prime of x is simply equal to 1/6 times the derivative of x to the negative 7th or we have 1/6 times negative 7 x to the negative 8. Pull the exponent out front and drop the power by 1. Again, pull the exponent out front. And dropped the power by 1. So h prime of x is negative 7/6 x to the negative 8, or negative 7 over 6x to to the 8th. Again, we're just taking advantage of the fact that dividing by x to the 7th, that's the same thing as multiplying by x to the negative 7th. So let's take a look at one more example. We wish to now find the derivative of f of t equals t plus 1 over t cubed. So if we wanted, we could use the quotient rule, or we can do some algebra manipulation. So f of t could be written as t to the negative 3 times t plus 1. If we wanted, we could use the product rule at this point, or we could go ahead and multiply that out. We have f of t is equal to t to the negative 3 times t, would be t to the negative 2. And then we have plus t to the negative 3. So at this point, we can go ahead and take the derivative. So we would have f prime of t is equal to, pull the power out front, negative 2. T to the, drop the power by 1, we would drop to negative 3. Then we have plus, we pull the power out front, negative 3. Then we drop the power by 1, so we have t to the negative 4. So again, to go from here to here, we pull the exponent out front. And drop the power by 1. We could leave this in this format, or we could rewrite it. We have f prime of t is equal to negative 2 over t cubed minus 3 over t to the 4th. Again, there are other formats this derivative could take. Once we get sort of more complicated functions, there are multiple formats that we can enter or we can write the derivative in at the end, and they will all be equivalent algebraically. So there is one derivative function, it just may appear different depending on how you go about taking the derivative, but you could always use algebraic manipulation to make it look like another format. So that is the expanded power rule.